Hello, everyone. My name is Kennette World, and I'm the Student, Faculty, and Young Professional Activities Coordinator at ACI. I'd like to welcome you to today's webinar on the ACI FRP Composite Beam Competition. We're glad that you could join us. This webinar will provide answers to some commonly asked questions and help you prepare for the upcoming competition. The learning objectives for this webinar are as shown on the screen. If you have questions during the presentation, feel free to use the chat box found on your screen to ask a question. We will try to address as many questions as we can at the end of the presentation. Now I'd like to introduce our speaker. Stephanie Walkup is an assistant teaching professor at Villanova University and a member of ACI Committee 440, Fiber Reinforced Polymer Reinforcement. Her specific research interests in FRP include the seismic retrofit of non-ductile reinforced concrete building columns using FRP jackets and long-term deflection of concrete members reinforced with internal FRP bars. Prior to her academic role, Stephanie worked for WJE, a national firm specializing in forensic engineering. She investigated complex issues and failures relating to a variety of structures, including residential, government, and commercial buildings, parking garages, temporary scaffolds, telecommunication towers, and driving range netting systems. And now Stephanie will begin today's presentation.
First, thank you, Kennette, for setting the webinar up. I'm hopeful that this will answer a lot of questions that students have had in the past and provide significant assistance in having the students complete their mix and cost forms, as that's been a difficult part for the students in the past competitions. So thank you for setting this up for the students. I just want to first show an image here on the screen of what the setup for the competition will look like so that the students are familiar with that. And we're going to go through just quickly a link that is provided on the ACI webpage describing the competition.
Concrete knowledge and skills each spring and fall at the ACI Concrete Convention and Exposition. Open to undergraduate teams at any college or university worldwide, the competition challenges students to demonstrate their expertise in various concrete concepts. Showcase your design, construction, and testing skills through the Fiber Reinforced Polymer Composites Competition. Choose between two categories of structure types. Incorporate fiber-reinforced polymers to achieve the lowest cost-load ratio and predict the ultimate load. Prizes will be awarded, and winners will be recognized by the American Concrete Institute. Visit concrete.org/students to learn more and begin building your FRP composite.
All right, so that just gives you a feel for what the test setup will look like on the day of the competition. So if we take a look at the learning objectives for the competition, we really want students to understand the similarities and the differences between steel and GFRP, or glass fiber reinforced polymer bars. Today I'm also going to provide some clarity to the competition rules, and again, understand how to use the official mix and cost form, the Excel file that is provided to the students. We'll talk about reasons that teams have been disqualified in the past. We certainly want that to be avoided at all costs. This is a significant effort that the students put in and significant financial contribution to attend the conference. So we want to avoid any disqualifications. And again, we'll talk about some questions that have arisen recently in for the competition. So the objective is to have the student teams design, construct, and test a concrete structure, again, reinforced with the GFRP, or glass fiber reinforced polymer bars. And in order to do so, the students also are looking to achieve the lowest cost to load ratio. And so we'll look at how that cost to load ratio is calculated, and also how the predictions in terms of ultimate strength and load it at a specified deflection are also calculated. So cost will be defined as the calculated batch cost for the concrete materials and the chemical admixtures. in addition to the cost of any FRP used to reinforce the structure. And the most important word I want to put out here is the batch cost. So it's not just the cost of actually casting your beam, but also what you need to cast to make your cylinders, to make your slump cone, and any excess materials that you're using. And there are penalties, adjustments for complicated geometries. There are also credits given for implementing sustainable design concepts. So we'll take a look at those. So again, the competition objectives are to create your beam, but also to predict the ultimate load that the member will be able to handle, and also to predict the load that will result in a piston deflection of 3.5 millimeters or 0.14 inches. So it's a cost to load ratio, but it is also in your predictions. Those both count toward winning the competition. So for the schedule, if you haven't done so already, you really need to get your team registered. Online registration opened in May, but it is continuing. You also need to upload your FRP kit order form and your school's letter of verification, and this is due in about 3 weeks. So if you have not done so, it's really important that you do this as soon as possible, because again, you really need to get your FRP kit sent to your school so that you can start beginning to construct your member. And then the official mix and cost form, which again we'll talk about later, as well as a diagram showing placement and dimensions of the FRP reinforcing materials, are due to ACI on October 2nd, or I should say by October 2nd, 2019. Certainly, if they're done ahead of time, you are welcome to submit those early. They should be emailed to students@concrete.org, and those mix and cost forms will be evaluated by members associated with the competition. If there are any glaring issues, we will try to reach out to you prior to the competition day. One of the new rules this year is that each school, whether that be a college or university, may only enter one team. In the past, we have allowed 2 teams, one to create a type 1 structure, one to create a type 2 structure. This is the first competition where we are only allowing the school to submit 1 team. And then they may choose either category type 1 or 2, and we'll identify what those are in a moment. Each team does need to have a supervising faculty advisor, and they need to consist of not more than 8 students on a team. The students need to be enrolled in an undergraduate program at the college or university. So I talk about type 1 and type 2 members, and we have images of what they represent up on the screen. So again, 1 entry, and you will choose either type 1, which means that your member geometry is straight from left to right, and it is prismatic, meaning that the cross section is the same if we take a cut at any point along the length of the beam. So prismatic, by definition, will have a constant EI, or modulus of elasticity times the moment of inertia, across its entire span. A cross-section that is symmetrical and also constant. So type 2, we see 2 different variations from type 1. Either the cross-section is straight, as shown in the upper right image, but it is not prismatic, or the cross-section is prismatic, meaning the shape is the same, whether we cut it at any point along its length, but it's not straight. It has an upward curve or a triangular shape to it along its length, right? So again, your team will need to choose one of these different types of structure. We're going to take a look at some specific geometry requirements, and I'm highlighting these specifically because these have resulted in disqualifications in the past. First, your member length needs to be between 950 millimeters and 1,000 millimeters. And this is to allow the structure to fit within the test frame and be loaded appropriately. I do not suggest coming to the competition with a member that measures exactly 950 millimeters or exactly 1,000 millimeters based on your measurement tools. All right, the operators and staff at the competition will be measuring your member, and if it measures 1,001 millimeters, you will be disqualified. So please stay within this range, but don't butt up against these minimum and maximum lengths. The structure also needs to fit into a 200 millimeter by 200 millimeter by 1,000 millimeter box. Okay, and this also has created problems in the past based on the skew of the geometry that the students have used. So if you need to construct a box to ensure that your member will fit into it, I do highly suggest it. Would build it maybe a little smaller than the measurements as shown. But you do want to make sure that you're staying within these geometry requirements. The tape measure or other measuring tools that are used on the competition will be the official tools. You may not bring your own measuring devices. In addition, your member needs to weigh between 5 kilograms and 15 kilograms. This has also been an issue in the past with disqualifications, mostly on the heavier end of the weight. So you do, again, want to make sure that you are weighing in under 15 kilograms, above 5 kilograms, and give yourself a little bit of leadway here. Don't be measuring in at 14.9. Prior to arriving at the competition site, you do need to designate the loading point, which is defined at mid-span, by marking an X on your member. This is where the load will be applied to the member, and it needs to be done so before you arrive at the competition. You also need to provide a school identification on both sides of your structure. And this is a 5-digit school identification code as indicated in the rules. So on both sides of the structure so that we can see it no matter which way the member is placed into the testing frame. End reactions, as well as the mid-span load, will be applied using 50 millimeter by 50 millimeter flat plates. And we see that those are occurring, again, both at the end support and at the top of the structure. So you would not want to bring, say, your member up to a point at mid-span. You will need to provide a flat surface for the loading plate to bear on your member, both at the end support and at the mid-span. The permitted FRP bars are those provided by ACI and those provided in the test kit only. In the past, we have broken open the members following testing. This is commonly done. If the failure does not expose the bars, your member will be disassembled, usually just with a mallet or a hammer, so that we can break open your member and ensure that the product that you are using in the concrete mix, as well as the FRP bars, are those that are consistent with the rules of the competition. So again, when you receive your FRP bars from ACI, please use those bars and those bars alone. Product data sheets for the bars were not shipped with the bars. However, they are available on ACI's website. The link is provided as shown. You are also able to get to the product data sheets using the links that are shown to the right of the specific bars. As you can see, you're provided with 4 different bar options: the Aslin 100 number 3 bar, the Pultrol V-Rod number 3 bar, the Tough Bar number 3 bar, as well as the Marshall Composite Technologies C bar. The top 3 bars are a sand-coated bar, and the Marshall C bar has traditional ribs, as you would find in a typical steel reinforcing bar. So they can be identified by their different coatings, sand coatings, and ribbing. We see an example of the data sheet for an Aslin FRP bar on the screen. If you go directly to the aslinfrp.com site, you'll need to click on the data sheet to bring up the actual product data. And in there, we'll talk about there are 2 values that you will want for design and prediction of your member ultimate strength as well as deflections. The FRP bar data sheets for Pultrol and V-Rod are shown as follows. They, again, are simply just a different product manufacturer. The important properties that you'll want to pull from these product data sheets include the minimum guaranteed ultimate tensile strength, that's denoted as F sub FU star, as well as the minimum tensile modulus of elasticity, which is denoted by the variable capital E. So those are the two values that you're going to want to work with in predicting your ultimate strength as well as your deflection. So if we take a look at FRP reinforcing bar properties, we see that they're different from a traditional steel reinforcing bar. Steel has a linear elastic response up until the point where it yields or begins to deform under the same load with continued deformation. We see that the fibers of the GFRP do not yield. They are linear elastic up until failure. When we combine the fibers with a matrix, the matrix is also approximately linear elastic. We see some plasticity towards the end of the stress-strain diagram. When we combine the fiber and the matrix, we form the composite GFRP reinforcing bar, and that is a linear elastic response up until failure. So GFRP bars are not as stiff as steel. We can see the three different types of bars as shown. Steel having the linear elastic response up until about 500 megapascal, and then becoming plastic and yielding. We see that CFRP bars, which are a carbon fiber polymer reinforcement, have approximately the same modulus of elasticity or linear elastic response, but that continues until rupture. There is no yielding. GFRP bars, which are the bars that you'll be using in this competition, are not as stiff as steel. They have a smaller modulus of elasticity, and they are linear elastic up until failure. So we get typically larger deformations when we use GFRP bars, but the ultimate strength may be the same depending upon the amount of reinforcing that's placed in your member. Now, to look at the design and prediction for your ultimate load and deflection, we would suggest taking a look at ACI 440.1R from the 2015 edition. This is ACI 440's guide to the design and construction of structural concrete reinforced with fiber-reinforced polymer bars. There are also other resources that you can take a look at, including AASHTO's LRFD Bridge Design Guide, the Canadian Highway Bridge Design Code, and the Federation International Tibetan FIB Bulletin 40. These other documents also contain information on design and prediction of concrete structures reinforced with FRP. For your deflection calculations, deflection is important, again, with GFRP reinforced members because of the lower modulus of elasticity or stiffness of the bars. So there are a lot of times where member design with structures reinforced with GFRP bars is governed by deflection. That's one of the reasons this is in the competition. So competition predictions will require calculation of the load that will cause a 3.5 millimeter or 0.14 inch midspan deflection. In order to calculate that deflection, you can use an effective moment of inertia, I sub EFF, and the equations for the effective moment of inertia are provided in ACI 440.1R. This allows calculation of the midspan deflection using standard beam deflection equations, but it also allows you to take into consideration both sections of your member that may be cracked and also sections that may be uncracked. For ultimate load calculation, you are required, again, for the predictions to predict the ultimate load of the member. And GFRP reinforced concrete flexural members may fail in flexure due to either concrete crushing or GFRP fracture. GFRP, again, bar behavior is approximately linear elastic until failure, so there is no yielding of the reinforcement. There are other failure modes that we have seen at the competition. So not only have we seen GFRP concrete crushing in a flexural failure or GFRP fracture due to a flexural failure, but we've also seen bond failures at the interface of the GFRP bar and concrete. We've seen shear failures, and we've seen other limit states as well. So it may be to your benefit to predict ultimate load based on different failure modes, including bond, flexural behavior, as well as shear behavior. For the concrete materials, you are only allowed to use materials listed in the official mix and cost worksheet. And we'll take a look at these specifically when we take a look at the worksheet. The cementitious materials include Portland cement, blended cement, slag cement, fly ash, and silica fume. The cementitious materials may not be used to coat reinforcement as a bond-enhancing agent. This has become apparent at previous competitions, and teams have been disqualified when we have identified the cementitious material bond enhancement. This is observed when we break open the member or it fails, exposing the bars. The aggregates must be non-metallic. And the only chemical admixtures that may be used are those consistent with ASTM C260, C494, and C1017. For the reinforcement, as I mentioned previously, it must be the reinforcement provided to you in your kit by ACI. You must include in your member a minimum of 1 full piece of FRP bar. However, that bar may be cut into smaller segments if you choose to do so, but you must place all segments of at least 1 full piece of FRP bar into your member. So again, reinforcement may be cut in any manner. You are not allowed to pre-stress any of the reinforcement. And mechanical anchorages, if used, must be made from the FRP reinforcing materials. You are also allowed to select different manufacturers of the FRP bars. For example, you may combine one Marshall C bar with one Aslan bar if you choose to do so. For the structure construction, curing must be at atmospheric pressure only, and the temperature must be less than the boiling point of water at the atmospheric temperature. The structure itself or the member itself must be no more than 56 days old at the time of testing. And no reinforcing supports may be provided in the 850 millimeter clear span. The reinforcing support must be within the ends of the member. Reinforcing supports must be made from non-metallic materials, or metallic materials must be galvanized or zinc coated, or coated with non-metallic materials. So let's take a look at the official mix and cost form. This is an Excel file that is provided to you on the ACI website. When you open the Excel file, you will see that it is noted for the ACI Fall 2019 Convention Student FRP Competition, Composites Competition. At the bottom of the Excel spreadsheet, there are 4 tabs. The first tab includes the instructions, as you can see shown on the screen. The next tab is 2A. It is the mix and cost form if you are using the form in US units. 2B is the same exact form, the mix and cost form, if you are using SI units. You must complete either Form 2A or Form 2B. You are not to complete both of these. The third tab is the FRP reinforcing diagram, and we'll talk about that further. You must complete this tab as well. Tab 4 in the Excel spreadsheet is a unit conversion tab, and then it is not to be used for you, but is referenced in some of the locked cells in the Excel file. When you enter the official mix and cost form, tab 2A or tab 2B, you are required to complete all of the light blue cells. Again, work with either sheet 2A or sheet 2B. Do not work with both. Make sure to complete all the cells or the mix and cost form will be returned to you. If they are not completed by the time of the competition properly, you may be disqualified. If a value is 0, not applicable to you, or equal to none, then you should be entering the value of 0, the letters N/A, or none into the spreadsheet. And we will see this in an example on one of the following slides. The bottom of the mix and cost form is shown here, and again, you'll be completing all of the light blue cells in the mix and cost form. So let's take a look at an example of one. First of all, the concrete materials that you are allowed to use for your concrete mix are shown as follows. You may not use materials that are outside of this material list. Coarse aggregate, fine aggregate, which includes a silica sand, lightweight aggregate, Portland cement, blended cement meeting either ASTM C595 or C1157, fly ash meeting ASTM C618, slag meeting ASTM C989, and silica fume meeting ASTM C1240. You will need water in your concrete mix, and you are allowed to add air to your concrete. All right, so we're just going to blow up one of the sheets. This is tab 2A in US units for the official mix and cost form. And we see that we are asking you to design, in the red oval here, mix design for 1 cubic yard of concrete. If you are designing a mix design for 1 cubic yard of concrete, that means that when you total up the volume in cubic feet for all of your materials, you should total 27.0 cubic feet. That is the equivalent of 1 cubic yard. So if your volume does not total 27 cubic feet, you have not given us a proper mix design. In addition, if you take the saturated surface dry weight of all of your materials and divide that by the volume of 27 cubic feet, you will get the density of your concrete in pounds per cubic foot. This value should range between 150 pounds per cubic foot for a lightweight concrete to around 145 to 150 pounds per cubic foot for a normal weight concrete. If your density is not in this range, this is a flag to somebody reviewing your mix and cost form. The water to cement ratio is actually a weight of water to the weight of the total cementitious materials in your mix. So we can see if we take the measured batch weight of water of 7.3 pounds and we divide by that by the total of the 19.1 pounds of blended cement, of type 1 cement, and the 3.1 pounds of fly ash, you will get a water to cement ratio of 0.33. So while it is termed water to cement ratio, the intent is it is a water to weight of cementitious material ratio. The batch size includes the volume of the concrete required, again, for not only your specimen itself, but also for 4 cylinders and a slump cone if the material in the slump cone is not reused for your cylinders, as well as any excess material that you need to batch the concrete. So the batch size is not just the size of or volume of the member itself. If it is just the volume of the member itself, it's an indication or a flag to someone on the review that the mix and cost form is not filled out appropriately. In addition, the date of cast needs to be no earlier than 56 days prior to the testing day. The measured batch weight should be equal to the density of your concrete multiplied by your batch size. So if we take 149.4 pounds per cubic foot and we multiply it by the batch size of 0.51 cubic feet, we see that we get the measured batch weight of 76.2 pounds. So again, these are checks that you should be making when you're filling out your official mix and cost form. We can see some other information for the mix and cost form down below, and that is two cells that you will answer in terms of yes or no. Is your cross-section rectangular? No or yes. Is your cross-section prismatic? This will help in determining whether you have penalties associated with your geometry. These are simply a cost penalty. So all of the costs and the sustainability credits are calculated by these pre-programmed spreadsheets. The sustainability credits are provided for reducing your cement content. There are limits that apply to this, and also by using fly ash, slag, or silica fume. However, the credits depend upon the percent of fly ash, slag, or silica fume that you have placed in your mix. Sustainability credits are defined in Section 4.4 of the rule sheet, and the formwork multipliers are defined in Section 4.3 of the official rule sheet. In the official mix and cost form, you will enter the number of pieces of reinforcement that you have used. These need to be in whole numbers because the cost of reinforcement is per bar. You may not buy a quarter of a bar or a half of a bar. So if you use 1.5 bars in your member, the cost to you will be the same as if you are using 2 whole bars. Again, the number of pieces used must be a whole number. You must again use 1 full length of 1 bar. And again, as I mentioned, any bar may be cut and bars may be mixed. Tab 3 of the official mix and cost form requires you to submit diagrams showing a cross-section of your member as well as the overall elevation or length of your member, including the reinforcement. Examples of those fully dimensioned are shown on the screen. We do expect a cross-section, including circular bars shown as in the upper right section of the screen, and we also require an elevation view along the length. Now, for the evaluation and results, the cost to load ratio is calculated as a value R sub 1. That is equal to the cost divided by the ultimate load that is measured. The ultimate load prediction ratio, R sub 2, is a percentage calculated by subtracting the ultimate measured value from that you predicted and dividing that quantity by the ultimate measured value. Similarly, the 3.5 millimeter deflection prediction ratio is calculated by subtracting the measured value from the value you predicted and dividing by the measured value and placing those in percent format. We will then rank the teams in ascending order in each of these 3 categories. You will be given, again, a ranking. The teams will be ranked separately in each structure type, so type 1 members are not competing against type 2. The final ranking is then calculated as 0.5 times R sub 1, which is your cost to load ratio, plus 0.25 times the ultimate prediction ratio and 0.25 times the deflection prediction ratio. Those teams will then be ranked and prizes will be given to the winning teams. Now we'll talk a little bit about past disqualifications, and I've mentioned these as we went along the presentation. First of all, teams have been disqualified for improper FRP bar size or type. Again, please use only the bars provided by ACI for the current competition. Even if your member does not fail exposing your bars, we will dismantle your member and we will verify the bars. The specimen did not meet the size requirement. It did not fit within the specified box or it was too long to fit in the box. Even if the specimen fits within the box itself, the concrete of the specimen, if reinforcement protrudes from the end of the specimen, then that does not meet the length requirement. Please know that the manufacturers of the reinforcing bars have cut their bars to an approximate length. Do not use the bars at these lengths without verifying that they meet the length requirement of the competition. It may mean that you need to cut the bar down slightly to meet the length requirement. Bars were coated beyond the sand coating provided by the manufacturer. Again, you may not use other materials to enhance the bond of the bars with the concrete surrounding them. The specimen was too light or typically too heavy. Again, I've mentioned this previously, but you really need to verify the weight of your member prior to arriving at the competition. You will not be able to modify your specimen once you are at the competition site. And again, please remember that only one entry is allowed per college or university. This is a significant change from the competition in the past years, where we have allowed both a Type 1 and Type 2 structure from a college or university. This year, you must choose either Type 1 or Type 2. You are allowed to have up to 8 students on the competition team this year, which varies from years past. The official mix and cost form only allows for entry of 5 student names. This was not changed from the competition in the past. You may simply enter 5 of the students that will be, including those who will be present on the competition day. The other 3 students may simply be listed on the original entry form. Other disqualifications include the official mix and cost form not being completed sufficiently. Again, it took some time today because I think this is the most difficult part for the students, to go through the official mix and cost form with you so that you understand how we're checking through your official mix and cost form. We are calculating values and making sure that they are adequate for the proper mix design. So please take time to work with your faculty advisor in making sure that this form is complete. We have also had many teams submit the official mix and cost form with only tab 2 of the Excel spreadsheet complete and without providing any figures. Again, you must complete either 2A or 2B, as well as the figures on tab 3. So I just want to go over, and I'm going to do this verbally, some of the questions that we have received to date. Can we make a hollow beam from inside, or is it against the rules? As far as the type of cross-section, you are allowed to create a hollow shape inside. However, nothing that is used to create the void, whether that be foam, cardboard, or any other material, may be left permanently in the structure. The final member, the final structure that you bring to the competition may only be comprised of the concrete made from the materials shown in the official mix and cost form, as well as the FRP reinforcements that you indicate you've used in the official mix and cost form, and bars provided by ACI. Can I put foam inside the concrete beam mix? Can we use foaming concrete as a lightweight concrete? Again, only the materials listed on the official mix and cost worksheet are allowed. Neither foam, such as styrofoam, nor reactive foaming agents that produce a cellular concrete may be used. So please make sure that your materials are consistent with only those provided on the official mix and cost form. Section 2.5.3 of the rules says that any type of non-metallic aggregate may be used. Is silica sand permitted? And what would be the unit price of the cost form of the material? Silica sand, which is an ultra-fine aggregate used in ultra-high performance concrete, is permitted, and it should be considered as fine aggregate on the mix and cost form. Be sure to note that silica sand is different than silica fumes, and silica fumes would not be considered an aggregate. The rules say that no support like wires or chairs are allowed in the middle clear span of 850 millimeters. But right now we're thinking about casting the beam with the FRP reinforcement hung from the top with tape, electrical tape or clear tape or thread. Are the tape or threads allowed to stay in the middle 850 millimeter clear span since they're not solid supports and won't have any structural contribution? The answer is no. Per section 3.6.3 of the rules, all reinforcing supports, regardless of the type of support used, must be located outside of the middle clear span. And just two more. According to the rules, section 1.2, each team must consist of not more than 8 students. But in the official marks and cost form, there was only space to put the names of 5 students. Again, you may list the 5 students, 5 of the 8 students. You are allowed to register 8 team members, as well as your faculty advisor. And can we have a section that is less than 20 centimeters by 20 centimeters? The answer is yes. 20 centimeters is the maximum width and maximum depth. There is no minimum dimension required for the structure, except for the minimum length of 950 millimeters. There are no minimum cross-sectional dimensions. However, as indicated in section 2.2, the structure must be able to be placed on the support and loaded as shown in the structure geometry requirement diagram. And the structure must also meet the minimum weight of 5 kilograms. So again, these are the questions to date. We are providing answers to all of the questions to date on the ACI website. I can pull it up here. So if you have additional questions and you think that they may have been answered in the past, please open up concrete.org, go to the student competitions and the FRP competition questions. You can scroll down through and read answers to any of the questions that students have submitted in the past. And now I'd like to take time to open up this presentation to questions that the users may have at this time.
Thank you, Stephanie. We do have a couple of questions in the chat box already, and I will read those given the amount of time that we have left available for the webinar. The first question is it possible to use shear reinforcement?
So they are allowed to use the FRP bars that are provided to them as shear reinforcement. However, they may not use any materials outside those in the official mix and cost form for the concrete mix and outside of the FRP bars. If they would like to cut the FRP bars provided to them to use them as shear reinforcement, they may do so.
Another question is superplastify allowed in the mix design?
If it is not provided in the official mix and cost form, they are not to use superplasticizer. So they will need to check in the additive as to whether it meets the ASTM. I'm scrolling back through here to get to that form. They will need to look in the chemical admixtures. It is in this section of the form right here. If they meet the requirements, the ASTM requirements in the chemical admixtures, they are allowed to use the superplasticizer. But there are very specific ASTMs required in there.
Thank you. Another question that we have is, can we cut FRP to use it as aggregate?
Any FRP bars that are provided to them may be cut and used in their member in any manner that they would like, provided they are accounting for the number of pieces that they are including in their actual member. So if they use, say for example, 1 bar for tensile reinforcement, for flexural tensile reinforcement, they cut 1 bar and use it for shear reinforcement, and then they take a 3rd bar, say, cut it for aggregate and mix it into the member, they would need to account for that as a bar that is used. I would say that that is not an aggregate, but that is a reinforcing. I will verify this with some of the other members that are chairing this committee, because that bar would not be listed in the concrete mix. It would need to be listed as reinforcement. So I'm gonna hold off, Jeanette, on actually answering that. I'm leaning towards no if they're including it in the concrete as aggregate, because again, they would need to put their concrete mix design in that list of materials, and that the bar would not be in there. If they're technically using it as reinforcement and not as concrete mix, that would be different. So I will have a posting to that answer provided on the ACI webpage for them.
Okay, thank you. Another question that we have is, can the FRP be exposed or should it be covered by concrete?
They're allowed to expose the bar. They may embed the bar in parts of the member and have it exposed in other parts. They certainly may do that. It does not need to be completely encased in the concrete. Yes, so exposed bars are permitted. That when they do that, typically what they're doing is going with a taller geometry shape, and I would just caution that they stay within the 20 centimeters of height and verify that they are meeting the size requirement with a box. So that is one of the areas when they start approaching these type 2 shapes and playing around with the geometry, which we certainly encourage. I love the creativity of this. But again, it is up to the students to make sure they're meeting those height requirements when they do that.
Is the T section considered a rectangular cross-section?
A T-shaped shape is not a rectangular cross-section. The idea behind this is that they would need to provide additional formwork beyond that of a rectangular beam. So the second that they start modifying the shape from a rectangular, true rectangle, single rectangle, they will have the formwork multiplier penalty in their cost. So no, the T-beam is not a rectangular shape. It is comprised of different rectangles.
Another question is, are you allowed to cast test beams before casting a final beam for the competition?
If they're casting, they should be including that in their batch weight. That's another one where let me talk with the other, again, people who I've worked with to set these rules. Whether that batch weight needs to go into their final batch or not, I will need to verify. I certainly encourage them to do that. They get much better predictions when they're able to do that. However, there really should be some consideration of that fact in their cost. So that's another one, Kenneth, where I'd like to talk with the other people who have put the rules together with me, and we'll post that to the website as well.
Okay. We do have a couple of questions related to the forms. In the cost mix form, under measured batch weight column next to SSD weight, will we only put the data that we actually use for our one beam and 4 cylinders plus excess mix?
Can you repeat that one more time now that I'm on the screen and I can look at the column they're referring to?
Okay, in the cost mix form under measured batch weight column next to SSD weight, will we only put the data that we actually use for our one beam and 4 cylinders plus excess mix?
Correct. So that is what they actually would put into the mixing drum or into their pan to actually mix their beams, their cylinders, the slump cone, and any excess. So that measured batch weight is the material that they are physically measuring out in their lab environment and truly mixing so that they can cast their member, their cylinders, make their slump cone, and give that measurement and any excess. That is correct.
Another student wants to know, how can we increase the number of members named to be the total 8 members in the cost sheet?
They're not able to do that right now. I do understand that they would like to have all 8 members listed There's pride in this competition. I have seen it. It's wonderful to see the pride that the students take. I will work on having a revised mix and cost form posted that allows for 8 students. Right now, they can only place 5. If they want to get started, that's fine. They don't need to list all 8. If they would like to list all 8, I will work on posting a new version that allows for 8 students. The problem right now is that they're not able to unlock. We really have this spreadsheet locked down so that they can only enter information in certain cells. They're not allowed to add rows or columns to the spreadsheet. So they are not able to do that themselves.
Okay, I think this one is also related to the form. It says, should the unitary mass be exactly as cost form, or is there an error range to fit in?
Can you read that to me one more time?
It says, is the unitary mass exactly as it is on the cost form, or is there an error range?
If they're talking about the 27.0 cubic feet for the volume, that needs to be exact. I mean, if they're giving me a mixed design for 1 cubic yard of concrete, then that should total for the volume 27.0. These numbers really are precise numbers that we should be able to verify when they provide the official mix and cost form. There really should not be ranges in these, if I'm understanding the question correctly.
Okay. Do we need to provide a cross-section diagram for a type 2 structure, not straight and not prismatic?
Yes, they do. They should provide at least one cross-section. If they are designing a type 2 structure that is not straight or not prismatic, they should be providing a cross-section. However, what they should do is denote where that cross-section is taken. So again, if you have a straight prismatic structure of type 1, then that cross-section will be consistent no matter where you take it along the length. If you're working with a type 2 structure, that cross-section may vary depending upon where they take the visual cut. So they should denote on the elevation where they are taking that cut to show us the actual cross-section. And if for clarity purposes, they believe that they need additional cross-section, they should be providing them. So again, if the shape is changing in cross-section throughout the length, they may want to provide 2 cross-sectional views of their member.
Someone asked, can you please elaborate on what is permitted regarding sand coating of FRP bars?
They are not allowed to coat the bars beyond the coating that is already provided by the manufacturer. When they receive their bars, if they haven't already, they will see that the Aslan and the Pultrol bars, let me go back to that slide here, they have an existing sand coating on them. They are not allowed to provide any additional coating. So you can see it with the Owens Corning, the Aslan bar. It has a helical wrap as well as a sand coating. The Pultrol bar has a sand coating, and the Tough bar has a darker sand coating. They may not coat these bars any more so than they already are by the manufacturer. The Marshall C bar does not have a sand coating. As you can see in the screen, and on the webinar screen, it has ribs very traditional to a steel reinforcing bar. They are not allowed to coat these bars. They must use them as is in their concrete.
Okay. There's a question that says, can we reuse the concrete for slump test in our structure that reduces
You
cost?
are correct. They are allowed to use the material from the slump cone in order to reduce their cost. They may use it in their member, they may use it in their cylinders. That is correct. And I should note also that they are required, this is important as well, I think one team showed up at the last competition without a cylinder. They are required to arrive at the competition not only with their member, but also with a concrete cylinder that's consistent with a mixed design. So the mix that they use for their members should be the same as that used to mold the concrete cylinder. But they may reuse the slump cone material to reduce their cost. Yeah.
Okay, you may have already answered this question, but it says, please clarify the use of reinforcement in the clear span of the member.
So the reinforcement that's allowed in the clear span of the member, the 850 millimeters, is simply the FRP bars that are provided to them. However, they're not allowed to use any chairing or supporting element for those bars in that clear 850 millimeter span. So this got back to the question of, can we put some tape in there? Can we put a chair in there to hang or support our bar? Nothing may be added to the member within the 850 millimeter clear span other than the concrete itself, the concrete material itself, and the FRP bars provided to them. So no chairing support or no other support in that 850 millimeter clear span.
Someone wants to know, are we expected to bend the FRP bars?
They're not expected to bend the FRP bar. I would, if they are attempting to bend the FRP bar, they may try to do so, but they're not expected to bend an FRP bar, no.
Okay, there's a couple of questions in here related to the ties. It says, what ties are allowed to tie diagonally cut FRP bars for shear resistance to longitudinal bars for flexural resistance?
Yeah, I need to review the rule sheet for this. Let me see if I can pull it up quickly here. As to the bars that they are, or the ties that they're allowed to use. And this might be one that I'll post on the website afterwards if I can't find it quickly here, because I don't want to waste time answering just one question here. So let me see if I can find it on my screen, and we'll go from there. Let's see. That would be in our testing, structure cost, definition. Structure construction. Let's see, reinforcing supports, and I'm reading from structure construction because this would mean the construction of their FRP bars. In 2.6.3, it states reinforcing supports are not permitted in the 850 millimeter clear span. We just talked about this. Any manner of bar support, including chairs, wires, and precast concrete blocks, may be used outside the clear span, as long as the bar support does not act to enhance the behavior of the structure, such as by anchoring the bar in the concrete. The bar supports are not included in the total cost. All reinforcement supports must be made from non-metallic materials or must be galvanized or zinc coated with non-metallic materials. Mechanical anchorages, if used, must be made from the materials provided as specified in section 2.5.7 and are included in the total cost. So my interpretation of this, I will verify this, is that if they are providing any chairs or supports in that nature to provide shear resistance, they probably need to be outside of that clear span. So again, I'll verify this and we'll post that answer to the website.
Okay, thank you very much, Stephanie. That's actually all the time that we have for questions today. If you do have additional questions, you can send those to students@concrete.org. That does go to the competition coordinator, who will forward that to the competition chairs. And as Stephanie mentioned before, that will be posted on the website for this competition under frequently asked questions. Someone did want to know if this webinar will be available for replay, and yes, it will. If you registered for this webinar, within a few days, I will be sending out a link so that you can view this webinar online at your leisure. Again, remember to order your FRP kits before the registration deadline of September 13th. And we look forward to seeing you all in Cincinnati. Thank you for attending this webinar today. And thank you, Stephanie.
Thank you, Kenneth.